Hello again, Calc 2 students. Here we are. We are entering Chapter 11, which has everything to do with sequences and series. It's a notorious chapter. It's a brand new section, brand new kind of math, I think, to all of us when we first encounter it. Basically, if you were to go, say, to 3 blue, 1 brown, and scroll down and click on Essence of Calculus, and then pick the video that talks about Taylor series. It'll give you a very good motivation for what we're about to do. He talks about being in physics and how they used a truncated polynomial, like a polynomial with like 2 or 3 terms only, to approximate cosine. And he's going, where do they get that from? They get it from this chapter. And by the time we're done with this chapter, we'll be able to develop our own. So it's really important. And the place we have to start in section 11.1 is we need to talk about sequences, okay? So sequences, first of all, because what we're going to do is a sequence is a string of numbers and a series is the sum of that string of numbers. The series is what we're going to turn into power series or polynomials that approximate other functions, and that's what we're going to learn to do in chapter 11. It's pretty exciting stuff, but we have to start at a very simplistic spot here. If a boring activity on a rainy afternoon, basically what you have to do is you think about strings of numbers in order. Okay, so what we end up as the topics is what's the notation that we use in math for sequences, finding the terms, finding a formula for the sequence, finding limits, and then finally a quick look at monotonic or increasing/decreasing sequences. I'm sitting on a creaky chair for some reason. I might have to fix that. Okay, so sequences, our sequences will have patterns to them. 1, 3, 5, 7. Actually, you might have seen that before. That's called an arithmetic sequence. Or 12 minus 6, 3, negative 3 over 2. What's going on there? It has another pattern. I'll let you think about that pattern. In my notes, I actually have done the thinking for us now that I see it. What we're seeing here that I'm circling, or here, is a fanciful way of writing out the formula for a sequence. Notice what it says. It says, for example, the second one says, curly brace, 12 times minus, 12 times minus 1/2 to the n minus 1. N is 1, 2, and as far as you want to go. Okay, so remember in math, the curly brace means the set. The set of what? The set of all of terms that look like this, and they are indexed by a counter, n. N goes from 1 to 2 to 3 to 4. And what happens is, as you plug those numbers in, you get the terms of the sequence. So if we continue playing around with this guy, we get, okay, so if n is equal to 1, the first term is 12 minus 1/2, 1 minus 1, comma. Notice what I did is I plugged the 1 in where the n is. In fact, if you want to see that, I can do that in color right there, okay? The rest are the same. 12 minus 1/2 to the 2 minus 1, okay? Next one, 12 minus 1/2 to the 3 minus 1, etc. And then you compute it. You go, well, the first one is 12, keep the color code going on. We got it's equal to 12, and it's times 1 because that's the 0 power. And then it's going to be comma 12 times minus 1/2 because that's the 1 power. And then it's going to be 12 times minus 1/2 squared, right? So we're in, and it keeps going, and we're ending up with, first it's a 12, then it's a minus 6, then because this is 1/4, it's a 3, right? Am I doing that right? 3, and it keeps going. So some people, math people, look at this as, what we're really staring at is we're staring at a function That is to say, all sequences, their functions from the set 1, 2, 3, the counting numbers to the real numbers. Okay? Could be anything. The formula could tell you anything. I'm going to try to make this one video, so I better hurry up and talk faster. Anyway, I wanted to introduce the notation to you. The first kind of notation is the set builder notation we just explored, but then I say usually they don't even do that. Usually what they do is they simply go, as I wrote here, A sub n, B sub n. Those are names of sequences, and it really says when you see, like in this example that we're going to work on, A sub n, that is the, basically each one of these guys is a formula for the nth term of a sequence or the sequence. So instead of wrapping it in curly brace set notation, n is 1 to infinity, it's all implied. So let's take a look at this one, and when we're done, we'll take a look at this one and we'll motor on. So the instructions say find the first 3 terms of each sequence below. Let's work on one at a time, okay? So A sub n equals 2n plus 1 over 3n plus 4. So to find the first 3 terms, you let n equal 1, then you let it equal 2, then you let it equal 3. Very simple. You're just plugging those numbers in. So the first number, I'll write this, the sequence is equal to, when n is 1, you get 2 times 1 plus 1 all over 3 times 1 plus 4, comma, 2 times 2 plus 1 over 3 times 2 plus 4, comma, 2 times 3 plus 1 over 3 times 3 plus 4, comma, and there's more if you want. That's it. Okay, that's it. All we do is clean up. So the top is 3, and the bottom looks like 7. So the first term is 3/7. The top next is 5, all over, what is this now, 10? Okay. And the top in this next one is 7. Do you notice a pattern up top? And the bottom is 13. Do you notice a pattern down below? If we wanted to continue the pattern, that's what's really important to us to be able to do. We should be able to look at this and go, oh, the next guy is probably 3, 5, 7, 9 over 7, 10, 13. How about 16? Let's go another one for fun. 3, 5, 7, 9, 11 over 19. And you just keep going as far as you want to go. Okay? So that's cool. The instructions said, I want these 3. There you go. I know how to use notation. I want you to do the next one. But the next one is kind of interesting because look how it's invented. So we're going to plug in n is 1, and then 2, and then 3. I might break this into 2 videos. And so our sequence B sub n becomes, watch, minus 1 to the 1 over 1 plus 1. And what's this thing mean? Factorial. Factorial. Quick lesson. So for instance, 5 factorial means 5 times 4 times 3 times 2 times 1. That is its definition. Why do we even bother with that? We see it a lot in this chapter. When we're building our series, sometimes we have to take derivatives to build series, and it ends up they pile up and become factorials. The coefficients do. Just to give you a heads up. That's why we study the factorials, not to make you crazy. All right, the next one is minus 1 to the 2 over 2 plus 1 factorial, comma. Next one is minus 1 to the 3 over 3 plus 1 factorial, right? 3 plus 1 factorial. And it keeps going. But let's look and see what these terms look like. The first one is negative 1 over, and then we have 2 factorial. Next one is comma, positive 1. Do you see how the flip-flop of the power, the sign change, the numerator changes sign, over 3 factorial. I bet that, yep, the next one is negative 1 over 4 factorial. And it keeps going. The reason that's a cool one to look at is 2 things. One, That's how you make the signs in the terms flip-flop and sign, plus, minus, plus, minus, plus, minus. Usually what happens in the definition to make that happen is they include a -1 to a power, to the n power. So it goes up, n is 1, 2, 3, 4, and the powers of -1 turn consecutively odd, then even, then odd, then even, and that changes the sign from plus to minus. Pretty cool. And the other part of this that's really cool is the factorial. We've never seen that before. To finish this guy off, we've got, this is 1 over 2 times 1, comma, this is negative. This is positive 1 over 3 times 2 times 1, comma, and this is -1 over 4 times 3 times 2 times 1. And if you want to wrap it up, you go, this is -1/2. The next one is 1/6. And the next one after that is minus, I think, 1 over 24. And the bottom, the top changes sign and the bottom change gets bigger and bigger factorial. So that'd be looking pretty good right there. Excuse me. So I think I'll stop this video right here with these last two examples. Okay, so we break it up into two pieces. All right, so what we're looking at here is another thing that we do in the homework in this section. If you want, you can pause and go back and rewind this thing to make sure you're good with what we were just talking about. Plugging in n is 1, 2, 3, 4 is easy. That's the easy part. The crazy part is looking at these series as they stand and maybe coming up with a formula for a sub n. That's where we earn our bread and butter in this case. So we're looking at, let's do a couple of these guys. Discerning the pattern is very important. It takes a little practice. So the end of this is what we want to say is, oh, I get it. A sub n is this formula. Maybe you want to call this guy B sub n. It's up to you. Those are just names. And that's what we want to be able to do. So let's take a look. We look at -6. I'm going to make some space here. 3 and -3 over 2. And what we do is we go, what if n is 1? What if n is 2? What if n is 3? How do we make it? There's a good video on this guy. It takes a long time doing it. Professor Leonard. I still mean to link that to you guys if you want to have a guy that's going to talk at you a long time and make sure you understand it. He's rather clear about things. It takes a while. His lectures are over 2 hours long, but don't let that put you off. Anyway, what he would do and I do and the whole world does is, how does 1 relate to -6? How does 2 relate to this guy? How does 3 relate to that guy? It's kind of hard to see, isn't it? But if you look up here, you can kind of tell after a while what's happening. If I go -6 to 3 and then 3 to -3 over 2, that's kind of like what we were looking at up here. I shouldn't cheat that way. But I'm thinking what's happening is we are dividing, right, by 2, or more likely multiplying by 1/2. So you got like -6 times 1/2. Okay, the next one. Oh, but wait, it wouldn't be, right? Because it'd have to be negative, right? Because he has to change sign to go to 3. So how about we make it negative then? Okay, I think that's the game. How did you know that, Weber? That's, well, you know, because in pre-calculus we have these so-called geometric series and we have these arithmetic series and all that kind of good stuff. This one is hard to see. The next one will be a little bit nicer to us. But what we're looking at is how do we go from -6 to 3 to -3 over 2? How do the indices n is 1 and then 2 and then 3 relate? Okay, so what we learn in pre-calc might be something like, oh, okay, -6 times 1/2 negative gets us to 3. But if I hit it with another -1/2, gets us to -3 over 2, and I think we're onto something. Okay, so every time we go from term to term to term, we've got a factor of -2. One way to look at it is you got -6, and then you got -6 times -1 over 2. And that's the second term. And then you have it -6 times -1 over 2, but then hit it with another -1 over 2, and that'll get us here. So the ultimate victory here is to say, you know what I think I'm seeing is that a sub n starts off with -6, but then every time you jump, you're multiplying by minus 1/2. If you go like n minus 1, if you go with n, then when n is 1, you end up here, but you want to start over here. So let's start with minus 1 power, which is the 0 power, and that is the solution to this. Okay? All right. I'm not saying that's easy. I think in the homework you're going to see stuff and you're going to go like, well, okay, so let me map it out. This one might be easier to see. It's a little easier to start with this one. So I have, there's a 5. And by the way, that's called A1. In fact, that's another way to write it. A2 is 8. A3 is 11. And A4 is 14. I think maybe we're recognizing what's happening in this case is we're just always adding 3. Some of you saw that, right? Some of you are going, oh yeah, that's what you're doing. That is what we're doing, and we got to somehow turn that into a formula for our guy here. So this is a lot like, this is an arithmetic sequence actually. It's a lot like what we did, but we're not multiplying, we're adding, okay? So how does 1 relate to 5? How does 2 relate to 8? How does 3 relate to 11? And so forth. Okay, so you got to like, how do I fit this thing together? Well, here we go again. You could go like, I'm starting with 5, but then what I want to do is I want to go to 8. So what I'm doing is I'm adding 3 for the next term. So the first term is 5. The next one is 5 plus 3. The next one is 5 plus 3 plus 3. The next one is 5 plus 3 plus 3 plus 3. Oh, see, the idea of pattern recognition is helping us here. So how about we write a sub n is equal to 5, and then plus a multiple of 3, but it's not going to be n, because if you go n is 1, you start here. You want to start back here. So it should be n minus 1, like so. That way when n is 1, you have 5. N is 2, now you're here. N is 3, n is 4. So the first term has 0 3s, the second one has 1 3, the third term has 2 3s, okay, etc. Now if you want, and it's a good idea, clean it up. You got 5 plus 3n minus 3. How about we tell the world a sub n is equal to what? 3n plus 2? When n is 1, you get 5. It's working. Okay, that's a bit brief, and you're going to be hitting the homework, and I can help you with that. But I'm going to end this video now, okay? And we'll get to the second portion in a little bit.